going to be looking at the Edexcel FP2 question on complex numbers from June 2011, question 6. In this question, we're given the polar equation of the curve C, and we're also told that there's a point A, which is a distance 5/2 units from the origin. We're going to drop a perpendicular from A down to the initial line, so we're going to look at the line AN, and we need to find the finite shaded region R shown on the diagram, which is bounded by the curve, the polar curve C, the initial line, and the vertical line AN. And we need to find the exact area for the shaded region for 9 marks. Before we start trying to find the area, we need to be able to find the position of A, and we're told that the distance of A from the origin is 5/2 units. So if I know that R is 5/2, I can sub that into my polar equation in order to find that cos theta is 1/2, and therefore theta is in radians pi/3. So we now know the coordinates of A in polar form have got to be 5/2, pi/3. Okay, so we've got all the information we need about A. Before we start thinking about the shaded area R, we need to find the area of the sector that contains the initial line, O to A, and the polar curve itself. So we're now going to find the area of that sector, quoting the formula, 1/2 the integral of R squared d theta. So we have the polar form of R, so straight away we know it's 2 plus cos theta. Don't forget it's squared, students often miss that bit out. And we know that the sector starts on the initial line, theta 0, and finishes at OA, where we've shown that theta is pi/3. Clearly we need to square out that bracket in order to be able to do the integration. So we're going to get 4 plus 4 cos theta plus cos squared theta. 4 and 4 cos theta are relatively easy to integrate. The problem is the cos squared theta. So I'm going to rewrite this again. So we're happy with the 4 and the 4 cos theta. But I need to think of another way of writing cos squared theta that doesn't involve the squaring. It's the squaring that's making it difficult to integrate. So using our knowledge of double angle formulae, I can rewrite cos squared theta with 1/2 of cos 2 theta plus 1 d theta. Now when I expand the bracket and collect like terms, we should have an expression that we will be able to integrate. So there's going to be 4 plus 1/2 is 9/2. There's 4 cos theta, and when I've expanded the bracket, there's going to be 1/2 of cos 2 theta as well. And the double angle cos 2 theta we will be able to integrate. So now we can integrate these three terms using the traditional square brackets. So integrating 9/2 is 9/2 theta. Integrating the 4 cos theta is going to be 4 sine theta, and integrating the 1/2 cos 2 theta is going to be sine 2 theta, but it needs balancing up with another 1/2, so it's going to be 1/2 times 1/2 is 1/4 sine 2 theta from 0 to pi/3. A good way of checking this integral is to differentiate it and check that it does give you a half cos 2 theta. We can now substitute the limits in. So substituting the top limit in first. So when theta is pi by 3, we're going to get 3 pi by 2 plus 4 sine pi by 3, which will be 2 root 3. And a quarter sine 2 theta is going to be an eighth of root 3. That's the top limit going in, minus the bottom limit going in. So theta's 0 now, so we're going to get 9 over 2 times nothing. Sine of nothing is nothing, and sine 2 theta is nothing. You must show evidence that you have put in that bottom limit. Expanding the bracket and collecting terms together, we get 3 pi by 4 plus 17/16 of root 3. So that is the area of the sector. We now need to find the area of the triangle OAN, and that will allow us to find the shaded area. So I need to find the length of ON. Don't forget, we know that the angle is pi by 3, so you might want to just make a note of that on your diagram. Therefore ON is OA, which was given as 5 over 2 cos pi by 3. So we can fairly quickly get ON is 5 quarters. We also need to know the height of that triangle, so we need to find AN, which is going to be OA, which again is 5 over 2 sine pi by 3. So we're looking for the length of the opposite side, and that will give me AN is 5 root 3 over 4. Therefore the area of the triangle OAN can now be found half times the base times the height, simplifies down to 25 over 32 root 3. So we found the area of the sector on the previous slide. We found the area of the triangle, just using half base times height. So now we can find the shaded area R. So the shaded area R must be the sector minus the triangle. And then when we collect like terms, we get the area is exactly 3 pi by 4 plus 9 over 32 root 3. And that's the exact area of shaded area R. The mark scheme for this 9-mark question allows a B1 mark for seeing that theta has been found as being pi by 3. There is a method mark for correctly using the area of a sector is a half r squared d theta. There is a method mark for correctly using the double angle formulae. An accuracy mark for the integration itself. So there's an accuracy mark for doing all parts of the integration. A method mark for putting both limits in. There's also a method mark for finding the lengths of the side of the triangle. An accuracy mark for the area of the triangle, and then a method mark for realising the shaded area is the sector, take away the triangle, and finally an accuracy mark for the exact answer. Notice the answer is exact, so the answer needs to involve pi and √3, not a decimal. You can get more information on the Further Mathematics Support Programme website, which is at www.furthermathematics.org.uk.